In the intense world of performance horses, we are quick to correlate their movement, manners, and success in the pen to their athleticism. But have you ever asked yourself to take a deeper look? Perhaps it's not a deeper look at the horse, but what's underneath them, the footing we ask them to perform on. Arenas are often made up of a sand and clay mixture and maintained through the combination of tractor dragging and watering to find the ideal uniform surface quality. We know that arena footing can be altered based off of surface composition, discipline, maintenance, and environmental effects. Our study aims to evaluate the soil changes that are created by these environmental effects. Over a 3 month period this spring, we will collect 3 samples per day from 5 high usage arenas in the Middle Tennessee area to analyze pH, particle size distribution, soil organic carbon, nutrient element composition, moisture, and shear stress. These physico-mechanical properties are directly correlated to both the peak load and acceleration a horse experiences in each stride, and consequently, their risk for injury. Using an Ulan sampler with a cylindrical core, we'll take around 143 cubic centimeters of soil from the top layer of these arenas. A pilot test was done at MTSU Horse Science Center earlier this year and demonstrated that within even a day, these soil quality parameters do change. This test also this test also confirmed that our collection of soil from the core of these arenas does not alter the base layer and further highlights the need for a deeper comprehension of how these variables may alter our horse's performance. The objective of our collection is to better support the horseman's understanding of these soil changes for more footing consistency, offering safe and sustainable surfaces that optimize performance. Thank you.
My experiential learning project has led me to partner with the Interscholastic Equestrian Association to create a Western judging contest that will be available to all IEA members. IEA hosts competitions across the United States that are accessible to any youth who have joined a team in their region and can be specific to Western, hunt seat, or dressage. These competitions run a draw-based format, meaning that the horses used in the show are provided by partner teams, which eliminates the need for riders to own their own horse. IEA is committed to promoting lifelong involvement in equestrian athletics and has built their foundation on widespread youth accessibility to educational opportunities and organized competition. The Western Judging Contest I am helping create will be available for any IEA member to participate in. This contest will consist of 3 proctored online sessions and an in-person final judging contest at IEA Nationals in Fort Worth, Texas. Each contest will require the participants to analyze and judge 5 classes: halter mares, halter geldings, horsemanship, branch riding, and reining. The first online contest will feature 5 horses per class. The first horse in each class will be evaluated via voiceover by professional judges to serve as an example of how the participants can expect to judge each class. The second and third online judging contest will contain 4 horses per class, which is standard for a judging contest. The in-person judging contest finals will take place at IEA Nationals and will run concurrently to the American Paint Horse Association's Horse IQ Youth Judging Contest. IEA members will be evaluated on their performance in the contest independent of those participating through APHA, and will have IEA member-specific placings and awards. The purpose of this contest is to provide educational content and opportunities for youth involved in IEA to grow in personal, professional, and industry-specific skills. Youth who participate can become more knowledgeable and passionate professionals as they move into adulthood, creating stewards of the horse and of our growing equine industry.
Hello, my name is Elena Mancera Andrade, and I am a PhD candidate in the Vicar Lab, and we are working on discovering new antimicrobial compounds. And so we all have experienced some kind of bacterial or fungal infections, and they usually go away with antibiotics. Sometimes the pathogen is really hard to kill, and we need a second or a third or even a fourth round of antibiotics. And that means that maybe the pathogen has become resistant to the previous ones, and that's why they didn't work. And if you haven't experienced this, maybe you know someone that has, because these type of infections happen to anyone and they are everywhere. Especially during the COVID-19 pandemic, the number of infections increased, and we were expecting them to drop after the pandemic was over, but they didn't. And so we need new compounds to fight these resistant pathogens. And so, in order to do that, we are working with peptoids, which are peptidomimetic compounds that are really similar to peptides, which they are part of the immune system and fight these type of infections. But the main difference is that the peptoids have the side chain attached to the amide nitrogen, and this provides stability against proteases, and they have shown a higher cell permeability compared to peptides. And so, great, we have new compounds. Yay. The question is, if we have a large number of them, how do we test them all? And this question was answered by the Beaker Lab a couple of years ago with the high throughput screening assay that is called the peptide library agar diffusion assay. It consists of a branch linker that is attached to a resin bead, and we synthesize the same compound on each strand. One strand is going to be used to the testing, and the other one is to characterize the compound. And so we create a large number of compounds, and then we test them by mixing some of the compounds with the pathogen and a reducing reagent. This reducing reagent is going to cleave the disulfide bond, is going to release the strand, and then the compound is going to be interacting with the pathogen. And so after an overnight of incubation, we will see some zones of inhibition, and that means that the compound killed the pathogen. And so we select those, and then we use the strand that was left over to characterize the compound. We use analytical techniques such as tandem mass spectrometry and high performance liquid chromatography to do that, but also we use the microbroth dilution method to determine how much that compound killed. And so that's how we discover new antimicrobial compounds, and we have had some really good, promising compounds so far.
Hi, my name is Emily Jolly. Our study looked into identifying biomarkers that are indicative of fatigue in racing thoroughbred horses. From prior research, we know that musculoskeletal injuries are the leading cause of death and lost working days to the racehorse population. Not only does this negatively impact the welfare of the horse, but it is detrimental to the industry as a whole. We know that a multitude of factors contribute to musculoskeletal injuries, but fatigue is of interest as it relates to changes in both biological markers and biomechanics of the exercising horse. Some frequently evaluated biomarkers are osteocalcin, CTX1, and stride length. Osteocalcin is a measurement of the amount of bone formation or building occurring, whereas CTX1 measures the amount of bone degradation. Stride length is the distance covered for one cycle of movement, measured from takeoff to landing of the same hoof. Currently, there is limited information that relates changes between pre and post exercise to biomarkers and biomechanics that are indicative of fatigue. So we hypothesized that biomarkers would increase or decrease in response to repeated bouts of exercise, and that biological markers would be changed in response to fatigue. So to test this, we took 12 mature, unfit thoroughbred geldings from Virginia Tech's Mare Center, and we subjected them to a baseline test week. This consisted of alternating days of exercise until fatigue test performed on the treadmill and blood serum collection days. Horses then underwent an 8-week exercise protocol consisting of low and high intensity exercise sessions. During week 9, horses then performed the baseline test week again. The results of this showed no difference in osteocalcin levels. CTX1 had a difference between week 0 and week 9, and stride length did not differ between day and week, but susceptibility to fatigue was different. So overall, the results of our study suggest that fatigue may have many factors that contribute to it, and not just one biomarker or parameter is responsible. Thanks.
Hi, my name is Elizabeth Aino, and I'll be talking on development of a cobalt complex catalyzed green approach for sustainable inoculation of amines. One of the principles of green chemistry is prevention, and it states that it is better to prevent the generation of waste than to create the waste and clean up afterwards. Inoculation of amines is concerned with converting primary amines to secondary or tertiary amines while employing alcohol as the alkylating agent. The conventional synthesis of this amine involved multiple steps. It involved the use of toxic reagents, and it also generates hazardous waste to the environment. To address this drawback, a greener alternative method evolved, which is known as the borrowing hydrogen method. This borrowing hydrogen method eradicates the generation of waste by generating water as the only byproduct, and this makes this method environmentally benign. This method also involves the use of catalyst, which in this case is usually a metal catalyst. Precious metals are being used for the successful synthesis of amines via the borrowing hydrogen method because they have high turnover or turnover frequency, and they are thermally stable. Our lab, however, is concerned with studying phosphotransition metals, which are known as base metals. We studied the fundamental differences between precious metals and base metals, and thus it has led us to report the successful synthesis of amines using a base metal, which is cobalt, for via the borrowing hydrogen method. In this system, the base required is 110 mole percent for the successful synthesis of amines. In this new work, we started by reporting a pentaligand. So we synthesized a pentaligand, and then we coordinated the pentaligand with a base metal, which is still cobalt, to synthesize a cobalt complex. And then we moved on to optimizing the reaction conditions using a model alcohol substrate and amine substrate. And then after optimizing the reaction, and we tested it across different bases, solvents, and at different temperatures, we got the condition that worked best for the system, and we were able to reduce the mole percent of base from 110 that we previously reported to 25 more percent, and this is in line with green chemistry. It is cost effective and eco-friendly, and we were able to achieve high efficiency. We also tested this across different substrates of aliphatic and aromatic amine and alcohol. Thank you.
A draw-based horse show is a competition where riders are randomly assigned to horses that they have had limited experience riding or even no experience riding. They are then judged on their rider correctness of position, maneuver scores, and overall appearance, and how they respond and acclimate to the horse that they are showing. There's a few different organizations that have these types of horse shows, such as IHSA, YIDA, and IEA. These are either college programs or youth organizations that conduct these types of horse shows. The one that we're going to talk about mostly today is the IHSA, or the Intercollegiate Horse Show Association. We actually have an IHSA team here, which you can see in my pictures on the slide, which are all from MTSU students showing in the IHSA throughout the last few years. And so we're looking to conduct a study at the 2026 IHSA Nationals. At this Nationals, we plan to collect horse data on body weights, heights, body condition score, past experiences or ownership of the horses, and what kind of aids you can use on the horse, whether you can use a crop or a spur or not. And then we plan on collecting the data such as the placings from the horse show and seeing if there's any patterns in the data that might imply that we could increase the fairness of draw system for these types of horse shows, or find that there might not be any patterns and that there's validity to these horse shows happening and that they provide students good, fair opportunities to succeed throughout their youth career or in college as well. We will run data analysis on this, and we hope to present this research at the 2027 Equine Science Symposium, and then hope to publish this data. This will have a good industry impact because these programs are super important and are becoming more increasingly popular across the United States. However, there's not a bunch of data or any research on whether or not it's fair or how important these programs are for student success. So what we hope to see within the education field of equine education is that this will provide some validity and back the fact that IHSA's mission, and also YITA and IEA as well, since they're similar formats, are helpful for and fair for students to participate in. And hopefully this can help programs get more funding for these teams to happen and provide opportunities to students. Thank you.
Hello, my name is Heather Green. I'm a PhD student in the Math and Science Education program at Middle Tennessee State University. Our lab is interested in the teaching professional development of graduate teaching assistants, or GTAs. GTAs are frequently the instructors of record across introductory biology courses, discussion sections, and laboratories. Because of these roles and their openness to instructional change, GTAs are a population for which professional development, or PD, could be particularly impactful. However, GTA PD varies across departments and institutions from completely absent to robust programs. This research study was part of a larger NSF-funded project that sought to understand why GTA PD is inconsistent or lacking in some departments. We hypothesized that there may be supports or barriers within departmental culture that either drive the development and implementation of GTA PD or act as a barrier to it. We used Reinholtz and Apkarian's Four Frames model as a theoretical framework for this study. The Four Frames model posits that there are four elements of departmental culture that can affect change: people, power, structures, and symbols. We utilized a semi-structured interview protocol to elicit supports and barriers from 35 GTA PD experts. These interviews were conducted via Zoom, which captured transcripts of their interactions. Research team members deductively coded responses as supports or barriers. In the next round of coding, those excerpts were coded into one of each of the four frames. Finally, the data were coded inductively within each frame to identify frequencies and commonality across themes. The largest percentage of individual codes were in the structures and symbols frames for both supports and barriers. Common codes for structures included courses or incentives as supports, and lack of time or lack of curriculum as barriers. Within the symbol frame, a common departmental vision regarding the importance of teaching and teaching training were reported as supports, while a departmental mission or vision focused primarily on research was reported as a common barrier. Using a broad lens, this study, when embedded in the known research, provides a clearer picture of the landscape of supports and barriers that departments face. It is encouraging that we found more support codes than barriers, suggesting GTA PD may be moving in a more positive direction. We also uncovered many promising GTA PD courses across our sample. With the largest number of codes in the structures and symbols categories, these data suggest a focus on structures and symbols when designing departmental change could be particularly impactful. Thank you.
Hi, my name is Ivan Lozano. I'm a graduate student at MTSU in the Math and Science Education program. My research interest for this particular project was how we can use LLMs to help students improve their mathematical definitions. Um, so this comes at a time where LLMs are being used in classrooms. Students are more eager to use LLMs. And UNESCO, the United Nations Educational, Cultural, and Scientific Organization, made a claim that in light of the quality of Gen AI's outputs, rigorous user tests and performance evaluations have to be conducted before validating these tools for large-scale or high-stakes adoptions. With that in mind, Dr. Schreier, my advisor, and I simulated 216 conversations with LLMs to find the odds of improvement based on four varying uh, things. First, quadrilaterals and arrays. We varied the type of concept that we were trying to define. Then we varied the initial definition from very accurate to very flawed based off of Tom Veneer's concept image research. Then we varied the model that we use, Copilot, ChatGPT, or Gemini, the most likely models for students to engage with. And then for the strategy of getting feedback, we varied it between agreement strategy, where we asked the AI to give us something it agreed with and disagreed with, versus the questioning strategy, where we just asked it to give us a question to help us improve our definition. We then took these questions and further coded them to focusing versus funneling questions. Focusing being questions that kind of push the students, or us in this case, to broaden our perspective, versus funneling questions where it kind of geared us or pushed us towards a particular definition. We used logistic regression to find the odds of improvements, which then we interpreted as odds to help us make sense of what we found. Here were our findings. The odds of improvement for arrays were substantially larger than quadrilaterals, likely due to arrays having fewer properties than quadrilaterals that are necessary for the definition. The odds of improvements were higher for definitions one and two, the more accurate definitions, likely due to the AI having more to work with. The odds of improvement for refinements, that was talk turns, were for one and two as opposed to three. This just meant there were diminishing returns. There's less to improve the more you improve something. The odds of improvements for agreement feedback were marginally larger than questioning feedback. This wasn't with everything held constant, unlike this up here. So it was just something that we found. This here's in red, this next finding, was because funneling questions tend to be the questions that we push educators away from using. We usually want them to use focusing questions, but the odds were higher for funneling questions, 12 times as much, which could suggest that students would engage in a word game with AI if they were trying to use AI in the manner that we used it here. And then finally, the odds of improvement for ChatGPT were larger than that for Gemini, but this was based off of models in early 2025. That could have changed in recent months. But that's it. Thank you.
Imagine you are a sixth grader and you've just finished an investigation in which you collected data. How would you make sense of it? You might notice certain values repeat, that most of the values are clumped together, that the smallest value is 12 and the largest is 263. You might begin to think about the meaning of the values. What does that 12 actually signify? You might even make a graph by ordering the values from least to greatest, grouping similar values, and using scale to show the range. To an expert, these observations and practices are routine, but to novice investigators, such as a sixth grader, they are not obvious and require significant support by teachers to develop them. This data fluency, or the ability to make sense of and use data, is a crucial skill in today's world. Research suggests that teachers' discourse moves, the actions teachers take to guide their classroom discussions, support students' sense making. Little is known, however, about how teachers use discourse moves to help students make sense of data. And so in my research, I use qualitative methods to understand the actions four expert sixth grade math and science teachers made to guide classroom conversations as they help their students make sense of the data they collected. I wanted to know how these teachers use discourse moves to initiate, sustain, and end student sense making. I used deductive and inductive coding to characterize the conversational moves teachers made during two data investigations, one in math and one in science. I used video data and transcripts to look for discourse moves known to support student sense making, the deductive part of coding. And I also looked for moves that came out of my data, the inductive part of coding. I found that these expert teachers often use discourse moves like "What do you notice?" to support students to make public their ideas and observations. These moves help students collectively know what they knew about their data and its context. Once these ideas were shared, however, these teachers frequently use discourse moves to change the topic or explain the topic, and students' sense making never got started. Rarely, these teachers use these ideas and observations as a basis to point out gaps or inconsistencies in an understanding. These discourse moves highlighted a puzzle or asked students to imagine a what-if scenario, and they provided opportunities for students to enter into the process of sense-making and begin generating explanations about their data. These findings suggest that teachers use discourse moves to elicit student ideas, but helping students connect them is challenging.
Hi everyone, I'm Maheshwari Waghela. I'm a PhD student in Molecular Biosciences program in MTSU. So since past 1 year, I have been working on a neuroblastoma. It's a pediatric cancer which originates in immature nerve cells and mainly occur in adrenal gland. So high-risk neuroblastoma have amplified NMIC, which has been linked to a poor prognosis of this cancer. Since NMIC is a transcription factor, it is undruggable. Therefore, we are using an indirect approach of targeting its one of a crucial cofactor for G9A, which can impair NMIC function. So here is my research model. As you can see, NMIC interacts with G9A and binds to the enhancer region of those target genes, which are involved in differentiations and are being repressed by this complex. So here are my research questions. Does NMIC requires G9A to its target genes? If yes, then at what region of that target gene does that complex bind, whether it's promoter or enhancer? And finally, what set of functional role does this target genes do? So to explore this, I did a cheap assay. It's a chromatin immunoprecipitation assay, which gave us a sample having a DNA which was bounded by G9A in presence of NMIC and in absence of NMIC. And then I sent that samples for sequencing and received the data and processed that data using following steps as shown in the slide and generated a gene list having genes which were bounded by G9A in presence of NMIC and in absence of NMIC. So I got the results. As you can see in the table, almost 80 to 90% of my G9A bound genes were lost when NMIC was silenced, when NMIC was absent. So, which indirectly answers my first question. And then I looked for the functional role of those set of genes. So, those genes were involved in development and differentiation of nerve cells. Then I looked for the region where this complex bind. As you can see, the most of the regions were far away from transcription starting site, that is above 1 kilobase pair. And as we all know, enhancers are located far away from transcription starting site as compared to the promoter region. So this also indirectly answered my second question. So with that, I would like to conclude that G9A is recruited by NMIC and it binds to an enhancer region of target genes. And those set of target genes are involved in neuronal differentiation and development. Finally, this study studies that pairing G9A inhibitors with chemotherapy could open a new and more effective treatment option for neuroblastoma. Thank you.
My name is Mahmoud Nabi, and today I'm going to present my research, what I did previously. For the development of any sort of biosensor, it's important to get perfect transducer material. Apart from graphene, molybdenum disulfide is getting more attention for the researcher because of its tunable surface gap and also its atomically thin layer. The research gap, what I am looking for in molybdenum disulfide basis biosensor is that molybdenum disulfide itself is negatively charged, and phosphate backbone of any sort of nucleic acid has a negative charge. So they repel each other. To do the charge screening, it's important to induce any sort of cation, and also it's important to get the charge inside of this sort of biosensor whenever we are inducing different condition as well. To get this information, first of all, I am using the colorimetry and also the Cottrell equation to measure the surface charge. For the characterization of my prepared ink, first of all, I run the TEM image and also the UV spectra and EDX analysis. The TEM image shows that there is a formation of the couple of layer, and UV analysis shows that this prepared ink has a semiconductive properties as well. And EDX analysis is actually give the information about the purification of my prepared ink. For the characterization, what I did, first of all, I did the incubation analysis of the with the metal ion. So, and also I'm doing the concentration analysis with the lock nucleic acid, with the monovalent and divalent cation. This result is also actually proved by the AFM analysis as well. As the monovalent and divalent cation has the contribution in the surface charge, so it's important to get which one has a better contribution. For that, I am actually using the chelation test. With the chelation test, I'm using the EDTA. As we know, EDTA is going to form the chelation on the surface with magnesium. So whenever I'm washing with the EDTA, so in all the nucleic acid, it shows that the charge is going to be decreased rather than the monovalent one. So it means magnesium has a greater contribution on the surface charge rather than the sodium. For the double strand one, as the double strand has a steep backbone, it shows a lower charge for both the cation, and also for all the biosensor, it's important to test with the non-complementary and non-complementary DNA. As I am not using any sort of surface blocker, so in that case, the non-complementary one actually shows the false positive charge rather than the complementary one. In overall finding, magnesium shows the greater contribution in the surface. It proved by the chelation test as well. And double strand one has because of the steep backbone, it shows the lower charge than the single strand one. And also non-complementary one shows the false positive charge on the surface. I acknowledge my previous research group, NIH for the funding, and SIU for giving me this nice opportunity to do the research. Thank you so much.
Hello, my name is Grace Bahar and I am a PhD student from the Mathematics and Science Education program. Today I am presenting some findings from my master's thesis, where I investigated how STEM students with math anxiety are navigating their academic careers. To start, math anxiety is defined to be the negative feelings that people get when doing mathematics. Many previous research on math anxiety tells us that students with math anxiety tend to avoid STEM majors that will require them to take more math classes. Although, recent research has shown the existence of math anxiety in high-achieving STEM students. So my study fills in the gap in the literature on the specific motivations of math-anxious students that allow them to keep persisting through their programs. As a result, I have found 3 themes from the responses of 10 STEM participants to the question, why are you still doing your STEM program despite your math anxiety? We'll look at statements from 4 participants, Cisco and Kiara, who are civil engineering majors, and Charles and Cheyenne, who are chemistry majors. The first theme is the security of outcome that the STEM field promises, which is a response for 4 participants. In particular, Cisco stated that he liked the job security that comes with civil engineering. And in relation to the next theme of having a passion for improvement in their respective fields, a response from 5 participants, Cisco wants to be part of something structurally revolutionary in the city, whereas Kiara's motivation for change is improving something that has been constantly ignored for many years, such as the water systems. And similarly, Charles is also motivated to help improve the environment through creating sustainable products such as alternatives for fuel. And lastly, familial support is also a strong motivation for 4 participants like Cheyenne, where she dedicates her successes and achievements to her mom and sister, who helps in pushing her to move forward. These are some motivations that STEM students with math anxiety possess that allow them to continue in persevering through their STEM majors despite their math anxiety. Participants' view of their math anxiety as something that can be managed has enabled them to not be hindered to be successful towards their end goals. And these results show us the importance of contextualizing mathematical concepts that relates to students' majors and interest, not only in STEM but also in non-STEM context, instead of only focusing on memorizing formulas and procedures. In conclusion, math anxiety is manageable when students have a strong motivational drive to overcome their anxiety. Additionally, math instructors as well as parents have the ability to aid in overcoming the students' math anxiety by providing them the proper support to be successful. Math anxiety is still a big issue to this day, but it can be overcome with appropriate supports from influential individuals. And that concludes my presentation. Thank you.
Hello, and thank you for taking the time to listen to my thesis topic today. My name is Marissa, and I'm a geoscience graduate student under Dr. Brittany Price. My thesis topic is concerned with the rising threat of detrimental flooding events within Middle Tennessee. My thesis aims to provide the historical baseline of extreme flooding events that this area lacks. This incomplete knowledge reduces our ability to properly communicate flood hazard risks to populations living in and around floodplains. Using sinkhole lakes in Smyrna, Tennessee, located in Sharp Springs Park, I tested two sediment cores in an effort to single out the catastrophic flooding event of 2010 as it reached the West Forks of the Stones River. By using proxies such as grain size analysis, loss on ignition, and magnetic susceptibility, I will provide needed context by analyzing the 1,000-year flooding event with known hydraulic conditions, thus providing a modern analog by which we can compare the magnitude of past flooding events to from the sedimentary record of this location. Sinkholes act as natural sediment traps, yielding valuable stratigraphic sequences that can be sampled via sediment coring. When a flood event occurs, floodwaters introduce a unique layer of sediment that can be used to identify the flood years later. We hypothesize that the lakes at this location formed from cover collapse, where the groundwater carved a cavity into underlying sediment so large that the cover sediments could no longer support themselves. Sharp Springs Park is located about 25 miles southeast of Nashville. The park encompasses four sinkhole lakes, each labeled in Figure 1. The study area lies within the limestone of the Central Basin. The bedrock here is the Ridley limestone of the Stones River Group, which was deposited in a shallow marine environment. Looking at Figure 1, you can see the difference between the flooding conditions of 2010 on the left and the non-flooding conditions of 2024. The sinkhole lakes are marked. My study site is Lake 2, where I took 6 sediment cores, only using the most proximal and most distal to the river samples to gauge how the sediments were routed during the flood. The Middle Tennessee area was under major drought conditions, as seen in Figure 2, just days before the 2010 flooding. The dry conditions were not equipped to handle the influx of water, which was over 11 inches of rain in a 2-day span. Preliminary results from Core B and F are seen in 3 and 4. During the first analysis of the results, I was looking for peaks in sand content and peaks in lithic material and dips in magnetic susceptibility, all of which are seen around mid-depth and towards the lowest depth in both cores, meaning these cores has captured a flood of some magnitude. Floods bring in grains of larger sizes and more lithic matter while also introducing material that has a different magnetic property. The next steps in this research is to date the core and further compare it to data previously analyzed from 2 other sinkhole lakes in the park. Being able to spatially correlate the distribution of flood event layers over the sinkhole basins will allow us to better understand how sediments are routed from the Stones River and allow us to evaluate the intensity of a flood as it reaches the lakes more distal from the river through correlation of layers. At the conclusion of this research, we hope to determine if the area of Middle Tennessee may be experiencing a higher frequency of flooding than predicted by the 100-year flood risk.
Hi everybody, my name is Mary Tran and I work with Dr. Kevin Baker in the Baker Lab in the Department of Chemistry. Today I'm excited to share my project on how we use a high throughput screening assay to rapidly identify new antimicrobial agents. Many of you have been prescribed an antibiotic by your healthcare provider. Antibiotics are used to treat bacterial infections such as strep throat, pneumonia, or skin infections. However, with the overuse and misuse of antimicrobial resistance has been a major problem. This means that the antibiotics are no longer effective at killing the bacteria that they were designed to target. For example, penicillin was discovered around 1940, and within just 3 years, bacteria had already developed resistance to it. And here's a timeline of showing when different antibiotics were discovered and when the resistance first appeared. And you can see there's a trend in just a few years, a lot of them are starting to grow resistant. The bacteria that my project focuses on is Staphylococcus aureus. This is a gram-positive bacteria that is very common but can become resistant to many antibiotics such as penicillin and vancomycin. You may have heard of penicillin-resistant Staphylococcus aureus, also known as MRSA, and it is considered as a serious health threat by the CDC. And in 2017, MRSA infections contributed to 1.7 billion healthcare costs, and that number continued to rise each year. To help address this growing issue, our lab has developed a novel high-throughput screening method called the PLAD assay. This assay uses a PLAD linker that allows us to synthesize our peptoid onto it with 2 identical peptoid strands called the alpha and the beta. We can also synthesize thousands of different diversity by using a common split and pool synthesis and then test them all at once. So here's how our plaid assay works. First, we mix our plaid-linked peptoid beads, an inoculum of Staphylococcus aureus, and a reducer reagent called TSAP into a soft agar, and then pour them onto a agar petri dish to incubate overnight. During incubation, the TSAP will cleave the alpha strand and allow it to interact with the bacteria, and it will release the peptoid, and if it has antimicrobial activity, it will create the zone of inhibition, which is a clear area around the bead where the bacterial growth is prevented. And then we collect the bead and cleave the second strand, aka the beta strand, using cyanide bromide, and then determine the structure using tandem mass spectrometry. Using this assay, I had over 40 hits of beads and successfully identified 6 peptoids with strong activity against Staphylococcus aureus, and I'm currently conducting further biological testing. This assay can be applied to a variety of other bacteria and fungal species, providing a rapid and effective way to discover new antimicrobial agents. Thank you.
Hello, my name is Michael Swanepoel, and I'm a PhD student in Dr. Justin Miller's lab here at MTSU. Today, I want to talk to you about biofilms and TPA, developing antibacterial and antibiofilm coatings for use against multi-drug-resistant Pseudomonas aeruginosa. So whenever we think about bacteria such as Pseudomonas, we typically think of individual cells growing on a surface. However, in reality, these microbes typically grow in well-developed communities of microbes known as biofilms. These biofilms are very difficult to eradicate, and they're even harder to prevent. And they often constitute a very significant clinical relevance as well, as they are the leading cause for hospital readmission post-surgery. That is, bacteria forming biofilms at surgical sites, as well as within ventilator systems. And we also see that these microbes cause a significant issue when it comes to commercial food contamination as well. Now, how do we address this? What we propose is to use a commonly used polymer known as polyaspartic acid, but we've tweaked it a little bit. Polyaspartic acid has been found to be used in these antibacterial and antibiofilm coatings, but in some cases, bacteria have found a way to break it down into a carbon source and use it for food, which is obviously less than ideal. In this case, we've tweaked the molecule just a little bit, and we have synthesized something known as thermally synthesized polyaspartic acid. And in this case, it's a little bit more resistant to being broken down, but also we wanted to investigate if we could improve these coatings by introducing something known as oleic acid, which is the major component within olive oil and also has antibacterial capability. So what we do is we combine these coatings onto a plate, if you're following with my graphical abstract at the bottom. And what we will try to do is grow Pseudomonas aeruginosa on these plates, whether it is a clean plate that does not have the coatings on it, or a plate that we've coated with both of these compounds, to see how a challenging environment can affect the development and overall structural capacity, building capacity for these microbes. So we incubate these in these wells, and then we visualize them using confocal laser scanning microscopy, using lasers to sort of elucidate what these different structures within the biofilms look like. And what you can see on the bottom right is after 72 hours of growth, Pseudomonas can really produce these beautiful biofilms with DNA that stretches across it like a sort of cargo net. And then once they're challenged with these antibacterial coatings, that is with TPA and oleic acid, there's significant reduction in this overall extracellular DNA matrix and the biofilm structure and organization as a whole. Our future steps are trying to develop a more broad spectrum approach to other pathogens within this segment. Thank you.
For my project, I partnered with the Tennessee Stockhorse Association to develop a series of educational videos designed to help their members better understand how the organization works and what to expect at ranch horse events. Tennessee Stockhorse hosts 4 to 5 ranch horse shows each year, offering classes in cow work, pictured on the left, reining, trail, and ranch riding. One of the features that makes Tennessee Stockhorse unique is its division structure, which provides opportunities for everyone from the brand new riders to advance to compete. A key part of my project was ensuring that the videos were accessible to a wide audience. To do this, I incorporated closed captioning along with written summaries so viewers could follow along regardless of their learning style. From there, I focused on the logistics of showing, topics that riders consistently reported needing more clarity on. One of the most important videos in this series explained how to read a scorecard. Judges use the scorecard to place riders in a class. To support this video at in-person shows, I designed a poster that includes a QR code linking directly to the scorecard video on YouTube. That poster is in the middle of the slide. We are currently producing a new video on how horse conformation affects performance and movement. In this project, we highlight key conformational features, such as the angle of the shoulder, shown in the photo on the right, and discuss how these physical characteristics influence the horse's movement and performance in the show pen. The second half of the video will demonstrate these features in motion, helping riders connect structure to function. All of the completed videos have been posted on the Tennessee Stockhorse Facebook page and YouTube channel, where they have received positive feedback from members. These resources not only improve understanding for current participants, but also help attract new riders by making information more accessible, clear, and engaging. Thank you.
Navicular is a very prevalent disease within the equine industry, and it is characterized by the degeneration and soreness of the navicular bone. You can see the navicular bone in the photo on the left, labeled E. It is often seen as heel pain within the horse, and a horse with navicular will typically load less weight onto their heels to try and relieve the pain through this. Around 1/3 of the four-limb lamenesses within the equine industry can be tied back to navicular disease. There are many different causes and many different physiological processes that go along with the development and characteristics of navicular. There are different treatments, including non-steroidal anti-inflammatory drugs and therapeutic shoeing. However, the chronic navicular diseases typically lead to a horse needing to have a procedure known as nerving. And nerving is when a veterinarian surgically removes a portion of the nerve in their heel region of their hoof, and this helps to take away the pain within the heel. So, paraneural analgesia is a term that we commonly refer to as blocking, and that is where we use a local anesthetic to simulate what a nerving would do to the horse and see if they respond to see if they are a candidate. In this case, we are using it to simulate if the horse was nerved, how does that change how they load their hooves? And so we have tech scan sensors. A photo in the middle shows them attached to the horse, and the photo on the right shows the sort of image that we receive from the data. And the red is the higher loaded areas with more force being applied, and the blue is the lighter areas with lower force. And then we will take these measurements before and after we block the horses. So we'll walk and trot them on a soft sand arena surface and the hard rubber tiled aisle surface that we have in our barn. We'll do this before blocking, and then we'll do this after blocking and compare the hoof loading in the toe and heel regions to see if there is a difference within how horses load their feet with their heel sensation and once it is removed. And this is a topic that has been in discussion within the equine industry if it is safe to continue use with horses once they have been nerved, as they do not feel the sensation in their feet. And typically, people will continue showing, running down, reining, doing fast turns and hard stops, also jumping. And it's just a welfare issue of whether or not this actually affects the horse when they cannot feel their heel region. So, my study will be looking to see if they do load their hooves differently once they cannot feel this, and if that would have an impact on how their performance and their overall well-being is. Thank you.
Hi everyone, my name is Nada Surur and I am a comms PhD student. I want you to imagine your bank trying to spot fraud in millions of transactions and Netflix is recommending your next movie. Behind these are networks where each entity is a node or dot and each relationship is an edge or line in a graph. The AI models that learn from these graphs are called graph neural networks. An example of that is this drug protein interaction network on the left, where a question we can ask here: how likely is taking two medicines together results in a specific reaction? One limitation of current research in graph neural networks is that they are very good at looking at your local neighborhood, but not so good at understanding role in the bigger network. For instance, in a collaboration recommendation network, think of two doctors who both specialize in cardiology. One of them is a bridge between cardiology and cancer research, collaborating across many departments. The other works inside a single small team. If an AI model cannot tell these roles apart, it may make the wrong recommendation. My research asked the question: how can we teach AI to see both the local meaning of connections and the global structure of the network? To do that, we designed a new AI model, and here's the core idea. First, we represent our relational data as a graph. Then, the model builds two complementary views of this graph. So one view captures semantic proximity, as explained mathematically in the middle plot. The other view captures structural position, which means where each node sits in the global network, as the plot on the left shows mathematically. Inside the model, there is a learnable gate which allows the model to adapt and pay more importance to one of these two views, because in some tasks, who you are connected to matters most. In others, where you sit in the network is crucial. Our model is important because it helps AI move from who is connected to whom to a bigger picture, which is who matters where in the network. To test this, we applied our model to 3 real-world benchmark networks used in AI research and compared it to 7 strong existing models. As you can see in this table and plot, our approach consistently performed better than those models in terms of accuracy and data points visualization after training, which tells us that local meaning is not enough, global structure also matters. Thank you for listening, and I hope you enjoyed my research.
So I'm going to start by talking about forage and what it is. It makes up a very large portion of our horse's diet, usually around at least 70%, if not the entirety of the diet. There's a couple different types of forages. We've got grass, which is like what grows in a pasture, hay, which is grass that's been cut and dried, and then legumes, which are nitrogen-fixing plants. They're kind of in their own little category, but they're very nutrient-dense and they still fall into forage. So the non-structural carbohydrates of these plants, the NSC, is going to vary a lot by forages and the forage type. It can range from 7 to 18% in haze alone. And so the non-structural carbohydrates, these are going to be these sugars and starches within the hay. And we have got some gaps in the research of how these sugars and starches impact our horses when feeding forages, which is an area we need to improve considering how much forage we do feed our horses. We want to have a consistent hay supply when we're feeding our horses, but sometimes this just doesn't happen. We'll have a bad growing season. You'll take your horse to a horse show, don't pack enough hay, and you'll have to rapidly switch what type of hay you're feeding it. So the purpose behind this study is to understand how the non-structural carbohydrates of the hay are going to impact the glycemic and insulinic responses of horses within these abrupt changes. There was a previous study done. That's what this graph is showing, is from in the middle. This shows the insulin responses to 3 different types of hay pellets. So this is a hay that's been chopped, ground up, and compressed into a little pellet. The way to build upon this study is that this, again, was done in pellets, which is not the most common form of forage. The most common form of forage is a long stem hay, which is what my project will be using. One important thing to note is on the right side of this graph, we'll notice that there's a very large spike in insulin. That right side represents oat grouts that were fed to the horses, which is a milled up version of oats. And this just kind of highlights how much the non-structural carbohydrate content can impact our horses. Horses can have a condition known as equine metabolic syndrome. It's the same as type 2 diabetes in humans, where they lose the ability to properly process sugar once it's in their bloodstream. So it's really important that we understand how to best manage this. The study will be done using 8 mature horses in a 4x4 Latin square design. We'll have 4 periods. On day 7 of our period, we'll be switching 3 groups of our horses to a new type of hay. The 4th group will stay on their control hay. And then we'll be doing blood draws every hour for 5 hours to monitor that glucose spike and insulin spike. We will analyze that data and hopefully use it to improve feeding recommendations and reduce the risk of non-structural carbohydrate-related issues in horses.
Hi, my name is Rahmi. I'm a PhD student from Biology Education Concentration. I'm studying how biology classroom can better support students with different religious identities, particularly when they're learning about evolution. Here's the problem. Many students walk into biology classes already feeling that evolution challenged their religious identities. Yet, research shows that instructors do not really acknowledge this. Some just ignore, and some just dismiss religion. When this happens, students disengage and learning become harder for them. So perhaps if the instructors address this concern respectfully, it will be more beneficial for students. But how? So we work with 55 instructors from introductory biology courses and survey more than 6,000 students before and after they learn about evolution. We measure evolution acceptance, understanding, religious identity, religiosity level, and other demographic information. In the end of semester, we measure evolution acceptance again and ask if their instructors use 2 conflict reducing practices. So for example, if students felt that their instructors allow them to have their own opinion about evolution or giving autonomy, and if the instructors show that they are religious scientists who accept evolution or showing role models. So after converting our measure to equal interval scale and use linear mix model, we test whether these 2 practices predicted student evolution acceptance in the end of the semester. Here what we found. First, autonomy matters. Students who felt that instructors gave them space to make their own judgment show higher acceptance of evolution by the end of the course. This pattern held for Christian, non-Christian, and non-religious students and across low and high levels of religiosity. So autonomy was consistently helpful. Second, role models show a more limited effect. We saw a small positive relationship overall, but the strongest benefit appeared only for highly religious Christian students. These students accepted evolution more when they saw examples of religious scientists who accept evolution. So, for students from other religious background, this practice was less effective, but probably it's because of the example presented usually from Christian role models. So what does it mean for teaching? Many instructors avoid topic of religion, but our findings show that it is simple. Just be respectful. Having a respectful practice can make a real difference. Giving students genuine autonomy and offering diverse role models can help support students and make evolution education more inclusive for everyone. Thank you.
Hello, my name is Richard Hohen. I'm a PhD student in the Computational and Data Sciences department. My main research focuses on using reinforcement learning, which is a subset of machine learning, to optimize agricultural truck routes. In specific, in rural America, these agricultural truck routes require heavy loads, certain space constraints, and time constraints of how the drivers can drive. The complexity comes in that you need to take those factors into account and not just distance to find the optimal route. In normal route optimizations, if you have 10 stops, you might come up with a factorial of 10 or about 3.6 million options to solve your shortest route. However, when you take other factors into account in terms of weight, which costs fuel depending on how much you're delivering, the sheer computation becomes somewhat infeasible to get done in a short amount of time. So my methodologies are more to take reinforcement learning, which provides rewards to a reinforcement agent when it finds a solution. So you don't calculate the problems, you kind of build a digital world and let this agent almost like play games on how best to find an optimal solution to the routing problem. As an example, I've got figures from A through D. A is essentially 7 random stops with drop-offs and pickups. When I take my agent without any real training in figure B and let it execute the route, you can see that it's somewhat random and highly inefficient. But just after a few training runs or playing the game of finding an optimal solution, figure C starts to crystallize out that he gets better and better. And after many different training scenarios, which takes time on a good computer, you get a really good result where you can see that it has a circular motion, and more importantly, it put the pickup at the end, which is when you take on more weight. So you're carrying more weight, which would cost more fuel, which the system correctly figured out is the way to solve the problem. I'm pretty excited about this, and the future will only get more interesting. Thank you very much.
So just this August, hundreds of thousands of Grok private AI conversation were exposed in the Google search results. Personal messages suddenly public. So this wasn't just a glitch, it's a flaw how we build AI today. It's by centralizing everybody's data. So now imagine a rural hospital in Tennessee and a major hospital in Boston, both wanting a better diagnostic AI. They can't share the patient's data, right? And they don't have equal computing power. How can they collaborate? So that's the challenge our research solves. So the problem we discuss, training large language model typically requires a pooling everyone's data and using massive computers. So this creates three issues, which is privacy violation, inequality, and computational barriers. So the solution to that is our core innovation. We use LoRa rank adaptation. It's low rank adaptation, which trains small plug-in module instead of full modules, cutting computational cost by more than 90%. So here is the innovation. Each device chooses its own adapter size. A phone trains a tiny rank adapter 4. Meanwhile, a laptop trains a rank 8 and a server rank 16. So this is a truly heterogeneous training. So to combine these different size adapters, we use singular value decomposition, where we break each adapter into US and V vector, like separating a song into bass, melody, and the rhyme. We then aggregate each component separately, weighted by each client's data, and reconstruct one unified global adapter. So this will allow phones, laptop, and server to collaborate and fine-tune the same AI model, uh, each contributing according to its capacity. So the real world impact on this is huge. So this will enable powerful collaboration in healthcare, in developing nations, in edge devices, and finance. So we are implementing this using flower federated framework with Distilbert. So this system supports 3 device tiers and track accuracy, perplexity, conversion speed, singular value behavior, and output quality. Also, early results show that stable heterogeneous aggregation across 10 clients over multiple rounds. So, AI should not be built by only the tech giants. Our research opens the door for everyone, one heterogeneous adapter at a time. Thank you.
If teachers view mistakes as learning opportunities in mathematics, their students are more likely to be not afraid of making mistakes, which helps them persist through academic challenges and thus develop positive mathematical identities. A part of my dissertation specifically focuses on nurturing pre-service teachers' positive beliefs about mistakes using WISE interventions, examining the research question, how do WISE interventions impact elementary pre-service teachers' view of mistakes in their introductory mathematics content course. Wise interventions by Walton and Wilson take an indirect approach to subtly guide participants towards the intervention's target through meaning making rather than explicitly stating the desired conclusion. For example, my interventions are designed as a set of qualitative surveys given throughout the semester to foster meaning making in participants while answering these questions. This meaning making from the message is reinforced through experiences in the course like growth oriented assessments and teacher messages that communicate the value of mistakes. One question from one of the surveys that targets view of mistakes asked my participants, how do you feel about making mistakes in math? Do you think it is important to avoid mistakes? Have you ever felt mistakes helped you learn mathematics? Although this specific survey item seems to be a series of questions, they're indirectly guiding the participants towards the target of the intervention that mistakes help you learn. To test the impact of the intervention, a week later, participants were asked, how important is it that your future students avoid mistakes? To analyze my data, I carried out an inductive analysis and developed themes that captured participants' perspectives on mistakes across various dimensions. I then sorted the developed themes into broader categories of positive, negative, and neutral views. An interesting finding is that most participants mentioned mistakes helped them learn, while none of them felt mistakes did not help, while some were ambivalent. Moreover, although some of the participants started their answers with negative perspectives of making mistakes, like feeling embarrassed or discouraged, there is an increase in the percentage of positive feelings about mistakes overall. Importantly, a week after the intervention message, most of them were okay with their future students making mistakes, implying the intervention message has successfully reached the participants and has an impact. However, participants who were ambivalent responded after a week that their future students must avoid mistakes. These results imply that to foster positive, lasting beliefs among ambivalent participants, they must be exposed to learning environments that explicitly model positive beliefs about mistakes, such as encouraging persistence through growth-oriented assessments and helping them experience struggle as a natural and valuable part of mathematical thinking. When pre-service teachers consistently encounter these practices throughout their teacher education program, they're more likely to carry forward productive beliefs about mistakes into their future classrooms and pass them on to the next generation of students. Thank you.
Hi everyone, my name is Sydney Myers and I'm a chemistry master's student at MTSU. My focus is chemistry education research, and the project that I am currently working on is the ethical application of artificial intelligence in chemistry education. There are a myriad of questions as to how AI should be integrated into education or if it should be integrated at all. And unfortunately, there's not a lot of answers out there. So the purpose of this project is to start conversations, initiate discussion among the different parties in chemistry education. It's really important to me to give a platform to students to share their opinions and their perspectives, because their opinions and perspectives are not being highlighted in the literature. And I very much value the insight that students have on this controversial issue. The methods that I will be using are twofold. First, I will be using an online survey sent out to these different parties in chemistry education. So undergraduate students, graduate students, tutors, chemistry researchers, and professors as well. All of the participants will be presented with situational questions where an ethical decision will come into play, and they can choose how much they agree or disagree with the action being taken. So questions regarding AI use of students on homework assignments or presentations. Should professors be allowed to use AI in the classroom to create lesson plans or grade homework assignments? Is there a correct way to cite AI on papers? Should it be cited? Should it be used on papers or reports or presentations? Personally, I didn't use AI for any of this presentation, but if I did, would that be ethical? Are other students using it? And am I therefore putting myself at a disadvantage? Should professors be teaching students how to use AI because it's used so commonly in the marketplace? Or should professors be encouraging students to stay away from AI because it's been used in many unethical ways? These are all questions that students are being faced with on the daily in the education system. And I am very curious how they're making these decisions and why. So part 2 of the method will be individual interviews. I will bring in participants for a one-on-one interview where I can really dive into how they are making these ethical decisions. What ethical frameworks are they using? How are they drawing these lines as to what is ethical and what is unethical? The current plan is to hold these interviews and surveys in spring of 2026, and I believe that the results of these will have very meaningful implications and impacts, such as if these groups in chemistry education are on the same page, then we can use that common ground to create a set of standards to be black and white across the board. But if there's discrepancies, then we'll be able to see what conversations need to be had between these two parties. I'm very much looking forward to having these conversations and challenging my own perspectives and beliefs on this topic, and hopefully I can challenge yours as well. Thank you.
Hi, my name is Tommy Mafe, and I am a PhD student in the Mathematics and Science Education program. Today, I'm sharing early findings from my dissertation project that I'm currently working on, which focuses on first-generation biology and chemistry students. These are students whose parents or caregiver did not complete a 4-year degree, which means they often have less guidance about how to navigate college system. Even though first-generation students bring meaningful cultural strength to STEM, they often enter departmental cultures shaped by objectivity and high-stake performance. Students can interpret this norm as signals about who belong in science. For first-generation students, these signals can heighten imposter feelings or identity misalignment. This project is grounded in 2 sociocultural frameworks. The first is the community cultural work, which highlights the cultural assets students bring, including familiar support, resilience, and community commitment. The second is the boundary crossing, which helps explain how students navigate different cultural space, and such as home, classroom, laboratory, and the department. The goal of the study is to understand how departmental culture and mentoring practices shape first-generation students' motivation, science identity, and persistence. Our main research question is, how do first-generation students perceive departmental culture, and in what way does mentoring support or hinder their experience? We are conducting semi-structured interviews with first-generation biology and chemistry majors for the next 3 years so that we can understand their long-term experiences with mentors and role models. What I'm presenting today reflects very early insight from only 2 students, and we expect these ideas to expand as we speak with more participants. So far, we're seeing 3 early themes. First, students describe their departmental culture as somewhat exclusive. As instructors offered less guidance in advanced courses, students felt pushed to be independent, but also questioned whether they belonged. Second, students' idea about mistakes changed. They initially believed that real scientists do not make errors, but through mentoring, they began to see mistakes as natural part of scientific learning. Third, students relied heavily on familiar encouragement to stay motivated. Mentors help them learn expectations and engage in authentic scientific practice, although mentors were not always aware of students' workload, which added stress for the students. Because this insight comes from only 2 students, we treat them cautiously. Still, they align with patterns commonly reported in the literature, particularly around exclusion and the importance of support in navigating scientific culture. As we continue gathering interviews over the next several years, we plan to look more closely at the cultural assets first-generation students bring and the ways mentors can intentionally support this asset to help students move confidently through science. Thank you for listening.
Hi everyone, my name is Yusuf Halik. I am a CBAS PhD student here at MTSU. Today I'd like to present our work on a quantum neural network for classifying fraudulent credit card transactions. Fraud is a huge issue for financial institutions, costing millions of dollars a year. For example, if somebody steals your credit card and starts using it, your bank will likely text or email you wanting to confirm the transaction. This is obviously a crucial service that banks provide, where accuracy and speed is very important. The bank's ability to flag a transaction and notify their customers as soon as possible is actually quite difficult and involves advanced statistical models. So the objective of this work is to compare one of those top performing models called a neural network with something we made called a quantum neural network. So what exactly is a neural network? Without getting too technical, a neural network is an algorithm that extracts meaningful information from data. Just like how our brains receive data from our eyes or our ears and then produces some kind of conclusion, Neural networks can do something similar, except it's all implemented using code and math and statistics, but they contain what's called layers. Our model has 3 layers, where each layer acts like a data filter that receives information and hopefully outputs useful information. For example, a model could receive a picture of a dog and then output, yes, this is a dog. If it's a cat, obviously that wouldn't be a very good model. But instead of picture data, we are feeding our network a data set of 10,000 normal transactions and 500 fraudulent transactions. Then we ask it to process that data and find the fraudulent transactions. If you take a quick look at the results table, you'll see that the classical neural network missed only about 15 of the fraud transactions, which is pretty decent, but our quantum neural networks perform much better. How and why did that happen? All we did actually was switch out the middle layer of the model architecture and replaced it with something called a quantum circuit. That consists of something called qubits. Qubits process information very differently from classical bits that we're used to, in that they can be either 1 or 0, or they can even be some combination of both. Nobody really understands how it's possible, but it is. We don't care about that. We just want to leverage this phenomenon and essentially evolve the way our network processes data. And when we replace that middle layer with a quantum one, we get significantly better results, as you can see in the table. This is because of an exponential increase in the computational capacity of the model. With 10 qubits, we miss only 9 fraud transactions, but with 15, we are only missing 4. That's a huge boost in performance, even when a small boost can result in massive savings for banks and their customers. And the methods we implemented could even be extended to a problem like anomaly detection in medicine. But at the end of the day, this work gave us crucial insights into the potential of quantum neural networks. Thank you so much, and I hope you enjoyed this research.
Hello, my name is Mansour Zakaria. I am a PhD student in the Mathematics and Science Education program. For decades, college science meant the big lecture, one voice at a podium, and hundreds of students taking notes. It covered content, but it didn't always spark learning. In recent years, universities have pushed for more student-centered classes. One approach many campuses use is the Learning Assistant module. Learning assistants are trained undergraduates who support instructors before, during, and after class. Our study focuses on courses that students traditionally struggle with, General Chemistry 1 and General Biology 1. I want you to think of instructor as the driver here and the learning assistants as the pitch crew around them, the preparation before the class, the in-class support, and the feedback. Our question is, which of these mechanisms actually change what happens in the class? We use teacher-centered systemic reform framework, and this framework helps us to understand why teachers use the practices they do, and we have started to study how learning assistance influences the connection between the teacher's thinking and their practices. We work with 5 instructors and 14 learning assistants at MTSU, using monthly check-ins, short classroom videos, and early interviews. Our analysis employs 2 lenses. We look for expected support, that is the before, during, and after, and read line by line for surprises. This allows us to see both what we expected and what we didn't expect. And here is the story the data tells. The preparation. An instructor said more engaging was to chunk things down before into a smaller bits, meaning planning together creates small doable steps that the instructor can try in the next class. What about during the class? An instructor said, I can see the moment they start to glaze over, then I do it again, meaning a brief pause with learning assistants circulating that will reset attention, allowing interactive work to continue. What about the feedback aspect? An instructor said, something I'm going to steal from you is a wording on a quiz, meaning LA spot confusing wording. Instructor fills it before the next meeting, leading to quick and clarity. Why does this matter? When we change the support around the teacher, that is the preparation, the in-class, and the feedback, we see the shift in how teachers think and small doable changes in what happened in class. These are early results. Next, we plan on adding faculty interviews and look at the other part of the module to complete the picture. If this pattern holds, program can take 3 simple steps to protect a short weekly planning window, ensure enough in-class early coverage, and add a quick class after check on activity and exam question, focusing on what helped the most. Big course teaching isn't a solo sport. The pitch crew, the preparation, the in-class, and feedback keep the team competitive. When you change the support around the teacher, you change how teachers think and what happened in the class. Thank you.